Hi, Dr. Patel. Thank you for joining us today. And congratulations to you and your team on winning a Positive Droplet Award. To get things started, can you tell us a little bit about some of the work you do?
Yeah, so I work in a Bristol Myers Squibb. It's called BMS, and that's we are engaged in the cell therapy, CAR T cell therapy uh, program, and so I work in particularly in a molecular analytics groups, and my work is mainly involve all those molecular assays. And one of this assay is very crucial, and this is also a regulatory requirement, like a vector copy number, because we use the vector to transduce the to transfer the gene in a human T cells. And this is a requirement that's when you put back those cells in a patient, we should have known that's how many number of those vectors are integrated in those. And there is certain number is kind of considered as a right limit. I mean, it's just a right number. If it is exceeding more number, it can cause the harm to the patient.
Obviously, it's important to quantify accurately, and of course, I'm assuming this is where digital PCR comes into play. Um, so, can you tell us some of the obstacles that you were able to get around with digital PCR versus using standard qPCR or other techniques?
Yeah, that's the part that my main role came. So qPCR based was going very smooth, and nothing was a problem because we are very used to, and everybody was confident. Uh, Once the advancement came, like we used to have a monocar therapy, like so one target all the times, like a one SCFBs we are transferring in a patient, and that targeting only one antigen. We advancing our programs, and now we have another two. It's called bispecific CAR. So that has two domain. And then when it comes to the analytical developments, we have a little challenge that how to address this. That's we have two. So we at this point we thought maybe we need to advance our analytical methods, and we are looking for the options like ddPCR. And I started exploring these things, and I found that this could be a best approach if I will follow this. And I start working, and I'll get a very, I would say like a very satisfactory data, and then everybody very happy once I will started this, and that's come to like a, I mean, it's very uh,
Well,
appealing.
the whole, yes. Well, we're seeing a lot of interest in biopharma for digital PCR for exactly what you're mentioning, accuracy of quantification, but also looking at vector integrity, making sure that um, the entire vector is in one virus, not bits and pieces everywhere. And of course, just titering the virus is a huge challenge. But digital PCR simplifies that process. So we're seeing a lot of interest and a lot of uptake in biopharma with this technology.
Of course, yeah. So I mean, when I interact with other people in the cell therapies companies, people often ask me, tell me why we use the ddPCRs. We have
Mm-hmm.
already, and which step you need to. And I answer, but that was not very like a appealing answer, like people can get buy it. But now I can say definitely yes, you have to buy it, because ddPCRs is really very sensitive and is a high precision. That is what we needed. And
Mm-hmm.
when you have a multiple attribute to detect simultaneously, like for example, like we have a biospecific car cams, now I need to get two steps now, not only the one. Just the vector copy number is not my only the game. I need a CAR T cells identification simultaneously. And the same time, the regulatory agency now asking, also you need to identify a one more attribute, that's how about if the patient has got prior CAR T cell therapy? So that's the point at the beginning of multiplexing. And the essay that
Mhm.
I develop here, that telling all those three criterias, like it's telling one is the car identity, it's telling the vector copy number, it's telling if the patient has prior CAR T cell therapy. So that's everybody like this because in one single PCRs you can get enough informations and accurate, and the precision is very very high, and that's what how our QC departments like it, and everybody.
Yes, of course. The QC departments want to make sure that everything is perfect. Obviously, there's a lot at stake, and patient well-being is one of the key factors. And but so it's interesting that you're mentioning the regulatory agencies because as a company, you always try to improve your methodology and make things as robust as possible. So it seems as though the regulatory agencies are seeing that you know accuracy can be improved, and companies are trying to get ahead of this. Is am I correct in this assumption that?
Yes, they also want like if the patients have the prior therapy and then any company are making similar products, they also wanted to know you should have each product their own identification method. Like we are using the one monoclonal antibody, one domain for one monocar therapy, and the same domain component coming in a bi-specific car that that's required. uh, we need to have identification methods for both. So you can say this number of attributes are going increase, and you definitely
Mhm.
need the method that can means without uh, compromising your data, you can get the best output of this, and this is the DDPCRs that's we come to.
No, excellent,
And
excellent.
most important things I like in this is the multiplexing. That's
Hmm.
that's multiplexing, and the one that when the QX1 came. And so I began my work with the QX200, but that's
Hmm.
not like took much attention because the multiple steps you go like manually.
Yeah.
So people like to do the work fast, more automations in a company rather just doing individually and going in a multiple steps.
So you have a QX1. Excellent. That's great to hear. I wasn't sure which platform you were using, but multiplexing is becoming more and more prevalent, and I think part of the challenge is that there's a perceived hesitation to multiplex in PCR because, at least for quantitative purposes, because with qPCR you can do it, but it's a lot of work. It's a lot of effort. Whereas, as you've experienced in digital PCR, it's a lot simpler. The process is a lot
Yeah,
smoother.
that's what all about. The DDPC as a droplet digital means you are. So I explain to people like you have a PCR impurity. That's the reason that you cannot do qPCR and like multiplexing up to four, three, 4 or 5 targets
Hmm.
because your impurities in a ddPCR is divided into 20 million. I mean 20,000 droplet.
Yep.
So basically, it's not inhibiting, not interfering by any impurities. So that's why it is
Correct.
you getting very high precision and sensitivity. So that's the one thing uh, I would say that the ddPCR has brought
Hmm.
a new.
I think it's an exciting field, and things are really taking off with digital PCR as a whole. Now, without spilling any secrets or anything else, what is your next set of projects with digital PCR?
I can tell that's like how many other places I can use the digital PCR, or I can even recommend based on since I have positive data and
Hmm.
positive step this. Now people will listening to me and will appreciate what I'm going to suggest them. So, you don't want just to do the testing once and finish. Now people want to test on every step of this product life cycle. So make a
Hmm.
simple assay that can be applied anywhere. Like if you are going to the patient, we clinician have selected the patient for gene therapy or the CAR T cell therapy, you can just do the simple test and you can say that's how much vector copy number and how many copies are already there.
Once again, thank you for your work and congratulations to you and your team.
Thank you.